feasibility of assessing locomotor respiratory coupling during running training. The physiological phenomena known as locomotor respiratory coupling, or LRC, measures the movements of the locomotor system influencing the breathing patterns. In human running and rowing, as well as bicycling, the leg movements and the torso movements create a visceral piston, basically moving the lung complex and causing the person to breathe at a certain pattern. This is measured in strides per breath, for example, 2 to 1, 4 to 1, and 1 to 1, and many more different ratios. My experiment was to assess if a similar large scale experiment would be feasible. In my experiment, I had high school runners train and measure their LRC before and after to see how it develops in the runners. For 4 weeks, the runners trained and increased their mileage. The LRC was measured with a Bluetooth headset for respiration, and an accelerometer from an iPhone was used to measure the locomotion. Issues that occurred during my experiment were that the treadmill noise was louder than the subject's breathing, so the microphone could not pick up the muffled breath. If to change something, I should have a larger sample size, a longer testing period, and I should have a more sensitive microphone or a different way of measuring. The purpose of my study was to assess whether future research on locomotor respiratory coupling would be possible. I wanted to see if just using an inexpensive microphone and a very easily accessible accelerometer would be adequate. I also wanted to see the effect of wind and treadmill noise on creating inaccuracies in microphone recordings. Also, I wanted to see if there would be issues with the accelerometer, such as rebound. Research that I did before the experiment included running and breathing animals. This article is the foundation for my research, and I consider it the Bible of LRC. It is the first time that LRC is actually talked about, and I was able to learn about LRC ratios and the visceral piston. They used a microphone, and I thought this was a good thing to use as well. In locomotor respiratory coupling develops in novice female rowers with training, novice female rowers were tested, their locomotor respiratory coupling was tested over a course of 1 season. This gave me ideas for the methods of my experiment, and I based a lot of things in my experiment off of their experiment. Lastly, ventilation and locomotions in humans, mechanisms, implications, and perturbations to the coupling of these two rhythms help me understand locomotor and respiratory rhythms and generally how these two rhythms connect. It helped me talk about and write about locomotor respiratory coupling, and it gave me a better grasp on analyzing data. For the methods of my experiment, I had 5 subjects, each were in high school. They were all on the running team, and some of them did other sports. Before I conducted my experiment, their parents had to sign a consent form, and they had to sign a consent form as well. Their VO2 max was tested before with a 1.5 mile run on the track. This was to make sure that each participant would increase their running ability and therefore hopefully increase their locomotor respiratory coupling ability.